Yo, what's up guys? Welcome back to another video. It's been a long time since I made a YouTube video talking about anything programming, let alone a YouTube video to be honest, but I want to make it quick. It's been over 2 years, a little over 2 years since I made my last programming video on this. And essentially it was a YouTube video kind of introducing a new series called Code With Me. And I created an open source multi-threading .NET library on camera for a bit. I didn't really finish it. I took on the project for like 6 months after that, but I didn't really get it to a point where I really wanted to put it out as a NuGet package. I think a year after that, I put it out as a NuGet package, but it wasn't quite done yet. And it's not quite done yet now, but it's enough for me to be like, you know what, you can actually use it in its current state. All the tests pass kind of thing. As you can see here, I have a bit of tests and it's good. It works. Is it limited? It is. But before we get into the limitations, what the hell is this project? What does it do for you? And, what is this video really about? So the TaskRipper is a .NET library, open source library, where it creates a very simple way to execute a delegate n times, n being any number you want, with that being the iterations. Now essentially it's a guided approach to doing this. The way I designed this library is I wanted to use the builder pattern to help you construct a contract, and then you give it some work into a work executor and you get some work result. Everything is kind of based on work. So as you can see, a lot of the class names have a work prefix. And so you know that, in order to do any work, you can look at classes with the work prefix. So for example, creating a work contract uses the work contract builder. We tell it the number of iterations, let's say 100,000. We give it a cancellation token of none. Now the library is pretty smart here. If you do give it a cancellation token of none, it will not go ahead and try to support it, cancellation for each iteration. So that's pretty cool. You could give it this is a concept in the TaskRipper, work balancing. And there's a couple options there. There's minimum threads, maximum threads, and none, or optimize. Optimize is kind of saying let TaskRipper kind of figure it out. And then execution settings. So this describes, if we take a look here, actually let's go in the code itself. Execution settings look like this. They have our thread range, which is the min and max range for threads that are available to use. Execution range, the min and max number of iterations to allow for a given set of work. And it comes with an execution environment. An execution environment just has a machine name and thread count. So I've implemented a version of this. This is your local one. And this will actually get your local machine name and number of threads by using the environment class. Now if we go back and we take a look, we can build it. So we get a work contract at the end of this. And here's an example of using the work executor. Now most classes have a default property, which means if you want to create any instances easily without understanding how to, build it, like a builder pattern, for example, how to construct a class, you can use a default property. So here's a work executor default, which means give me a default instance of this. That looks like this. If you're curious, where's a work executor? Here's a default instance, which is just a work executor. Okay? And if we take a look inside, we give it a contract, we give it a function to execute, and request is like the input of the function right here. So the return type of this function is string, and the input is an int. Now, keep in mind that cancellation token is embedded within the contract, so you don't need to decorate your methods with cancellation token. The contract embeds that for you. You could take any action and execute it n times. whether it's 100,000 iterations of it, 10 iterations, whatever you want. But basically what's possible right now is if you want to perform the same action n times, you could do that. The limits are that if you want to change the input and output between iterations, let's say the first iteration, you have an input of 5 into a function, and you want to increment that per iteration. So the next iteration would be 6, 7, and so on. That's not supported right now. That would be a lot more useful, but it's something that's on the future plan. In other words, it's a stateless, kind of interaction. Another thing that I want to do is fire and forget support, which means you don't have to await the task. Right here, this work that you execute, even though it's multi-threaded, you're still waiting for all of it to finish. So yes, it's multi-threaded, but you're still waiting for it. Typically you want to multi-thread something maybe and fire and forget it. Let it kind of process in the background and then pick it up when it's done. This is a fire and forget approach where we're going to use events to listen to when it's done. And basically the purpose of this video, guys, now that I've described all of this, is for those people who want to help contribute. Now, the purpose again of this entire library is to have a simple approach to multi-threading. I want to be able to support different actions, like where we could pass in the Fibonacci number function, because the output determines the next input, which determines the next output, etc. So in order to support Fibonacci, we need to support stateful actions. So basically we would have to update the way we wrap our functions. So in the work executor, here's an example of wrapping tasks. So this is essentially what's happening. We either wrap a task, so this is a smartness if it's if we use cancellation token or not. If the token is none, which is an empty token, we don't wrap it. But if we do use a cancellation token, we throw it per iteration. So for so there's n tasks, that's the number of threads. Each task has a certain number of iterations for the thread, right? Each iteration, we're going to support cancellation. We're going to run the action delegate with a certain request. We're going to get the result, and we're going to queue the result into the result queue. But again, if we want this to be more smart, we're updating this. This is our task wrapper, right? And we need to wrap it to support stateful functions like Fibonacci. And this is where we could come in and have the open source community contribute and kind of get this going. That's really the purpose of me making this video, guys. It's not to showcase all this crazy work or anything. It's a pretty simple library. It is useful to some extent. Is it very useful? No. That's the truth. But I did create this project to start open source development, and this was a little over 2 years ago. I think it still has potential. I've already built it to a point where you can for example, you can execute a delegate n times. Let's say you want to performance test your method and see how well it does under parallel execution. This is perfect. I mean, this will do it for you. Your results measure time and all of that. It's very simple. In my tests, I have it outputting the duration. So here's one iteration, takes this much ticks. And here's one less than int max, takes almost a second to run. So multi-threading is powerful. I have a pretty beefy machine, so this is why it executes so fast. All I'm doing is printing an integer to a string. It's nothing crazy. But anyways, guys, that's going to do it for today. The roadmap is kind of on the README. So if we want to have a look, this is kind of the roadmap. Feel free to fork the repository and create pull requests. And, let's make it happen, guys. I would love to see this library have a bit more features, because something like this, guys, if you are able to support just Fibonacci by itself, the usefulness skyrockets, because now you could start easily, like literally this easy, multi-threading functions in your code base that requires more than one iteration. It's very, very good. And you don't have to really know anything about multi-threading to do it. It's kind of guided this way for you. Thanks for watching, guys. If you have any questions or comments, leave them in the comments below, and I'll see you in another video. Peace out, guys.